So let's talk about inverse functions. There are lots of functions in mathematics, and certainly lots of functions in this class that we've been using. Some of those functions can be inverted. Now, what do I mean by that? Every function consists of inputs and outputs, but only some of those functions can I reverse the process. If I give you an output, do you know what the input would have been? Some functions can do this and others can't. So we've actually been working with a lot of different invertible functions already. Here are some examples on the screen. The inverse of y equals 3x minus 1 is x equals a third of y plus 1/3. The inverse of y equals e to the power x is x equals the natural logarithm of y. The inverse of y equals x cubed is x equals the cube root of y. Now, you might notice that all of these are algebraic manipulations which we can reverse. If I give you one of these equations, you can solve for the x and figure out what x is as a function of y. Now, some functions do not have this property. For example, a squaring function. If y equals x squared, then we actually lose information when we go to compute x squared. If I tell you that the output of this function is positive 9, do you actually know whether or not my input was positive 3 or negative 3? Without any extra information, there's no way to tell. So what's the difference between these things? The invertible functions have exactly one input value for every single one of their output values. So the technical language for a function like this is that the function is called one-to-one. Now, if you're more geometrically minded, you can also think of this in terms of the graph of the function. So here is y equals f of x. And if I try to invert it, what happens if I graph x equals f of y instead? I get this sideways parabola, which isn't a function, right? I know it's not a function because it fails the vertical line test. Oh, that gives me an idea. So if my original function fails a horizontal line test, if there is some horizontal line which crosses the graph of the function in two different places, and the function is not one-to-one, and the function is not invertible. So we can use this to graphically tell if a function is one-to-one or not, and whether or not the function has an inverse. So here's another function, y equals sine of 3 times x. It's this nice wave function. And I can do the same thing where I just flip the graph and see what I get. And this definitely fails the vertical line test. This is definitely not a function. Now, we're going to get back to fixing functions in a little bit. How to make an inverse for a function which is not one-to-one. But let's actually think about what it means in terms of derivatives to calculate an inverse function.